My background is in electronic and electrical engineering, which I studied as a master's degree at University of Strathclyde in Glasgow. After I completed my degree, I went into industry, but I chose to undertake an engineering doctorate, which is like a industrially research-based PhD. My exposure to FEA simulation started way back in 2003 as a summer research student in the Centre for Ultrasonic Engineering in Strathclyde, and I started off using FEA to simulate the performance of imaging transducers. And as my career went on, as I moved into industry, I started to use finite element simulation to design sonar arrays. So everything from basic sonar sensors all the way through to quite advanced forward look or side scan imaging systems, which are used for ocean floor topography and bathymetry. And simulation is really crucial in these applications. It's very expensive to prototype some of these devices, so there's a huge value in being able to assess the performance of a design before you actually put it into production. And we were quite successful in developing our simulation to the point that we reduced the number of prototypes and ultimately got products to market a lot more quickly than we'd previously done. OnScale is an engineering simulation platform that allows engineers to run simulations on very powerful cloud hardware, so it gets them results quickly and removes some of the traditional constraints that are associated with engineering simulation. So when you talk about the benefits of OnScale, it's only natural to talk about the cloud. And when I think about finite element packages and the challenges that they traditionally face, there are a few ones that really jump out, and these are the ones that OnScale is directly addressing. So finite element is typically very memory intensive. It is typically very computationally intensive, and the problems take a long time to run. And OnScale addresses both of these issues head on. We're very memory efficient, and in tandem with that, we give users access to cloud compute nodes, which naturally have huge amounts of memory. We can access nodes with terabytes of memory, a lot more than would typically be available to your average design engineer. And what we've achieved there is essentially to take memory limitations out of the equation for engineers doing FEA. The second point I mentioned, runtime for models, which is typically very long in FEA problems. We address that head on again by having a very efficient time domain solver. We make extensive use of structured grids using an explicit formulation, which allows us to be very computationally efficient. But on top of that, our ability to split models across many nodes on the cloud gives us the ability to throw a lot of compute power at difficult problems. And This elastic use of cloud computation is really what allows us to deliver huge problems in very, very short time frames. And when I say that, we are typically orders of magnitude faster than traditional FEA packages. So the cloud is key to what we're able to deliver there, as are our solvers. Most of the mainstream finite element packages were unable to handle the large time domain problems that are typically encountered in acoustics. We were very fortunate. We worked with very closely with Strathclyde University, and we started very early using the solvers that were really the precursor to the solvers that are used in OnScale today. So we were quite early in trying these solvers and really putting them to the test on quite challenging and advanced problems. So OnScale uses a range of multiphysics solvers. One of the reasons that we're very fast is that they're very tightly coupled. And in terms of the different physical areas that we cover structural mechanics, both linear and non-linear. We cover elastic wave propagation. We cover thermal analysis, electrical analysis, both piezoelectric effects and electrostatic coupling effects. The background of our solvers is that they've been used very heavily in ultrasonic applications, so a variety of both wave propagation and piezoelectric transduction applications, and these range from biomedical devices to sonar to non-destructive testing of structural components, and then start to get into more general sensors and actuators. And our solvers have been used extensively in these areas for the last 20 years. So OnScale is very fortunate to count a range of Fortune 50 companies in their client base, and as you can see from our website, we're working with a wide number of multinational blue chip tech companies to try and deliver the next generation of product advancements that they seek for their customers. There's a mixture of reactions from clients when they see what we can do. Everything from genuine excitement and elation because they look at what we're doing and they say, wow, this is the tool that I've always wanted, all the way through to, stunned disbelief, and a bit of engineering curiosity. How can you do this? How come we're able to make such a big step forward? We have a range of teams here in Glasgow. We're currently at 15 people, and those are spread across our engineering, marketing and software development teams. But we're continuing to grow. We're actually just in the process of acquiring new premises very close to where we are just now, and that's going to let us continue to grow our team in Glasgow, which, as someone from Glasgow, that's a very exciting prospect. 3 of our 4 founders are Scots, so we like to think we've got a proud Scottish heritage to what is very quickly becoming a very global company.